All right, in today's lesson, we are going to be exploring the three types of subatomic particles that make up an atom: the electron, the proton, and the neutron. We are going to examine their properties, and we are going to learn how to figure out how we can determine the number of protons, electrons, and neutrons for neutral atoms. And to do this, we are going to need our periodic table of elements. So make sure that you have this on hand when you're going through this lesson. Okay, so if we refer to the note set on atomic structure, you read here that all atoms are composed of three types of subatomic particles. And subatomic particle means particles that are smaller than an atom. And there are three. There's protons, electrons, and neutrons. So the first one we're going to examine is the proton. So the proton has a positive charge, and it's located in the nucleus of the atom. And so for the sake of simplicity, we usually consider the charge on a proton to be +1, or what we call +1 elementary charge. Now, the number of protons inside any atom is always equal to the atomic number of the element. So the number of protons always equals the atomic number. So for example, if we go back to our periodic table, you'll notice that on the top left of every element, there is a number. So for example, silicon, the atomic number is 14, which tells us there are 14 protons in the nucleus of silicon. So that's pretty much it about protons. That's all we really need to know for grade 9 is to determine the number. And so if you know the atomic number of the element, then you know the number of protons. So for example, if we said some element has 37 protons, we could go to the periodic table and look for element number 37, and it would be rubidium. So that's kind of how that works for protons. Electrons then are negatively charged, and they are not found in the nucleus. They travel around the nucleus in specific paths called orbits or shells, as we're going to investigate in the Bohr model later this week. And so for the sake of simplicity, if electrons are negatively charged, we say the basic charge on any electron is to be -1. So kind of the opposite charge to a proton. Proton is +1 elementary charge, and an electron is -1 elementary charges. So the number of protons in an atom is normally equal to the number of protons. And that is if the atom is electrically neutral. So in that case, then the number of electrons as well would equal the atomic number of the element. And that's only in the case of, this would be for neutral atoms only. Okay. Put that in red. Add that in there. So for example, up here for silicon, silicon is atomic number 14. Silicon is a neutral element, so it would have 14 protons as well as 14 electrons. The neutron is a little different. The neutron has no charge. It is said to be neutral. It is located as well in the nucleus of the atom. And because it has no charge, we say that the charge on a neutron is 0. So the neutron is located in the nucleus of the atom as well as the protons. And so the number of neutrons in an atom can be determined by subtracting the atomic number of the element from the mass number. So that is how we get the number of neutrons. We take the mass number, subtract the atomic number. The mass number is the decimal number that is given on a periodic table. So for example, silicon is 28.086, that's the mass number, okay? It's usually written on the bottom on a periodic table, and it is the decimal number. That is how we recognize it. So if we look at this example here, silicon has an atomic mass of 28. It has an atomic number of 14, so 28 minus 14 would be 14 neutrons in one atom of silicon. So the mass number of an element is the average mass of a single atom of the element and is measured in atomic mass units. And again, the atomic mass of each element is given at the bottom of the periodic table for each element. So what we can do with this is summarize. We usually have, instead of writing the names, we will write the symbol and the charge. So the symbol for proton, neutron, and electron is just the first letter, P for proton, N for neutron, and E for electron. Because protons are positively charged, they have a plus, and electrons are negatively charged, so they have a negative. So P plus for proton, N for neutron, and E minus for electrons. Again, the location, protons and neutrons are found in the nucleus of the atom, and the electron is found in the electron shell. Protons and neutrons each have an atomic mass unit, and the electron has no mass. So how do we use this information then to find out the number of subatomic particles? We'll look at a specific example here. So determine the number of subatomic particles for each type in a carbon atom. So the element carbon. So the first thing we need to get is the atomic number. And the mass number. We need to round to the nearest whole number. So we go to our periodic table and we find carbon. Carbon has an atomic number of 6 and a mass number of 12.011. So the atomic number is 6 and the mass number is 12.011, which we will round to 12. Again, we always want a whole number. So carbon then trying to get the symbol. So the number of protons in carbon would equal the atomic number, which is 6. The number of electrons in carbon is equal to the atomic number as well, which is 6. And the number of neutrons would equal the mass number 12 minus 6, which of course equals 6. So carbon has 6 protons, 6 electrons, and 6 neutrons. That's pretty much how it works. For any element, you simply get the atomic number and you find the mass number, you round it to the nearest whole number. The protons and electrons are equal to each other, to the atomic number, and the number of neutrons is equal to the mass number, subtract the atomic number. So we can look at an element that's a bit bigger. We'll look at gold. So how many subatomic particles are in gold? So I'll just copy this over. So the element is gold, and the atomic symbol for gold is AU. And if we didn't know that off by heart, we would look on the table. I just know that because I've been doing this for a long time. And we need to know the mass number and the atomic number. So we look on the periodic table and we look for the name gold, and gold is right here, and it is the symbol AU. So the atomic number is 179, and the mass number is, sorry, not 179, the atomic number is 79, and the atomic number is 196.967, which would round up to 197. So the atomic number is 79, and the mass number is 197. So next, in order to do this, we will figure out the number of electrons, the number of protons, and the number of neutrons. So let's copy and paste this over. All right, so the number of protons will equal 79 because that's the atomic number. The number of electrons as well equal to 79. And the number of neutrons in this case would equal the mass number, 197, subtract the atomic number, 79. And that would give us the difference of 118. 197 minus 79 is 118. So gold has 79 protons, 79 electrons, and 118 neutrons. So that, grade 9s, is how we figure out the number of protons, electrons, and neutrons in any atom, any element in the periodic table. So we could do this for all elements on this table. Again, make sure the mass number, you round to the nearest whole number. You either round up or you would round down. Do not use decimals for the mass number, please. For grade 9, you need to be able to do the first 30 elements, which you'll be doing tomorrow in a worksheet, but really you could do this for any element. So here, this example, we can complete the following table. So we got some information and we're going to figure out the atomic number, the mass number, protons, electrons, and neutrons. So again, when we know the protons or the electrons, that's going to be the same as the atomic number. So that's important, but we'll go through this step by step. So we've already done carbon. We know, we will make that centered. So we know that carbon's atomic number, we figured it out, was 6 and its mass number was 12. So it's 6 and then mass number 12. It had 6 protons, 6 electrons, and 6 neutrons. So the atomic number 14. Now, as soon as we know the atomic number, we automatically know the protons and the electrons. So we can fill that right in. 14, 14. So let's go figure out on the table what atomic number 14 is. So we go to our table, we find 14, and it's silicon. So before we go back, we'll look at the mass number. It's 28.086. So that rounds to 28 for the mass number. So this would be the symbol, sorry, put that in the center. Silicon, mass number is 28. So 28 minus 14 would be 14 neutrons for silicon. All right, we might have to go digging a bit deeper for the mass number because we actually have to look and find it, but we're going to find the rounded mass number of 39. So we go to our table and we find our mass number of 39. So we have 28, we have 30, we have 32, we have 39.9, and we have 39.0. So it would be potassium, not argon. Interesting, argon rounds up to 40, and potassium rounds down to 39. So this is element potassium, which is number 19. So this is the element potassium. Its atomic number is 19. It has 19 protons, 19 electrons, and we would take 39, I'll show the work, 39 minus 19, which would equal 20 neutrons. So I'm just showing the work there. I'll bold the answer. So 20 neutrons. Okay, so the element with 4 protons, we know it's going to have the same number of electrons, which is 4, and we know that that's the atomic number of 4. So we can go to the periodic table and find number 4, which is beryllium, capital BE. And beryllium's mass number, rounded, is 9.012, so it would be 9. So the mass number would be 9. And the number of neutrons, I won't show the work this time, it would be 9 minus 4, which would be 5 neutrons. Okay, so our last example, our last part of example 2, we're starting with the number of electrons. Well, if we know the number of electrons is 26, there must be 26 protons, and the atomic number must be also 26. So we'll go to the periodic table and find number 26, and it is iron, Fe. And We look for the mass number on iron. It's 55.845, which rounds up to 56. So we type in 56. And to get the number of neutrons, we take the mass number, 56, and we subtract the atomic number, 26, and we get 30 neutrons. So I hope this kind of makes sense what we did here, filling in this table. I could give you a blank table like that with different examples, different pieces of information, and you can fill it in. Again, remember that the number of protons is always equal to the number of electrons in a neutral atom, and that number is always the same as the atomic number. The mass number, subtract the atomic number, always yields the number of neutrons. Okay, so the last thing we have, and this is a little bit of extra information. This is a little bit opposite to the periodic table, but we have what's called standard atomic notation. So standard atomic notation is a common notation used in chemistry and physics to indicate the atomic number and mass number of an element. So I'll highlight that for you. It's opposite to what you see on the periodic table. Here, the mass number is on top, whereas on the periodic table, the atomic number is on top. So the standard atomic notation is opposite, okay, to what you see on the periodic table. It is written by writing an element symbol, and then the subscript is the atomic number. So subscript, the atomic number, and the superscript, or the exponent position, is the mass number, and it's written on the left side, not the right. So if we wanted to look at the standard atomic notation for carbon, make this bigger, and I'll put this in the center, and I would insert this. I'm going to insert this as an equation, and I'm going to look at the superscripts and subscripts on the left. So we would put the atomic symbol for carbon, which is capital C. Again, we look on our periodic table and we find carbon. Its a mass number is 12.011, so 12. And its atomic number, of course, is 6, which goes on the bottom. So that would be the standard atomic notation for carbon. Okay, so our last example here would be looking at the standard atomic notation for antimony. So we'll just make that a bit bigger, and we'll do the same thing. Insert the superscript and subscript on the left, and we'll go find, okay, the atomic symbol for antimony. So we look for antimony, antimony, antimony. There it is. Antimony, the symbol is Sb, and the atomic number is 51. So capital S, little b, and the atomic number is 51. And we look at the rounded mass number. It's 121.76, so that would round up to 122. And that is how we write standard atomic notation. So just a little side note on this. Do not get confused that the standard atomic notation matches the periodic table notation, because of course the atomic number is always on top. And again, if you always are confused, remember that the mass number is always the decimal number. So you can't mess that up. The mass number is always the decimal number on the periodic table. So what we've done today is we've looked over defining the 3 types of subatomic particles, looking at their symbols, and then learning how to determine the number of subatomic particles in each type. So I recommend you go back and you fill out the rest of these notes, and you complete example 2. And tomorrow there will, on Wednesday, there will be a practice worksheet, and I'll be uploading both of these to my website today. So this covers the lessons for Tuesday and Wednesday, so April 14th and April 15th. I hope you guys are doing well, and I hope you had a good Easter, and I hope that if you have any questions, please email me, and please don't forget to check the new schedule that I have uploaded to my website. It is a learning schedule for the rest of the year. Again, this learning schedule is all based on the fact that there might be remote learning until June. If we end up going back to school, then that schedule will change.